I am the Associate Vice President for Academic Technologies here at Purdue. And I'm going to be talking a little bit about some of Purdue's infrastructure in terms of both the research side and the teaching and learning side. And it's just try to help put some things into context from this morning's set of presentations about what cyber infrastructure is, what it can do, everything from in rather simple, I hope I didn't finish, visualizations to, as I put it when I was talking to Carrie Troy, kind of the visualizations on steroids. When you get an opportunity to be able to do something on in an IMAX theater. So my group's mission really is all about three aspects. It's to support, it's to empower, and it's to advance the use of this cyber infrastructure for both research and teaching and learning. And these aspects are very important to me in terms of, we try to provide as much support as we can, but ultimately, we will never be in a place where we'll have, one person to provide support for every faculty member that's on campus. Those types of things don't scale. So we have to get to the point where we actually are able to empower the faculty, the staff that are involved, and even the students to the point where they can do some of this work themselves. And then the final component is really about advancing, and you'll be seeing more and more of this, is finding those opportunities based on interactions with people on campus and interactions with technology providers where we can actually do something new and unique on campus to make things better, whether that's teaching and learning, whether that's research. So let me talk a little bit about the research computing aspects here. Some of you may have seen some of these numbers, but the group over the past several years have been focused on how can we provide critical services. So in the past year, we're about 136 million hours of computation that occurs. Part of this comes about from our efforts with the TerraGrid, which is a national network. Some of this deals with looking and working with 167 faculty members. And that's part of that is just a fraction of the story, because oftentimes what we find in working with faculty is for every faculty member we work with, we often will work with 4, 5, 6 students that are involved as part of their research. As Carrie Troy mentioned in one of his questions in the opening, one of the key pieces about cyber infrastructure really is about the people. The people that can help make things go. The people that can work in collaboration to make things happen, whether that is to help them learn to do some of this on their own, or whether it's just to get them through a particular tough spot. In terms of the research people, we have people that do support, we have people that do the systems, we have programmers, we have what we call research scientists that partner with faculty on funding opportunities. In the past 3 years, we typically submit somewhere around 40 proposals. We're averaging right now about 38 proposals, about $48 million, of which we're, on average, over the last 3 years, we are able to get about 16 awards. And almost all of these are in collaboration with different faculty members. There's been a couple of references. Carrie Troy mentioned about using the codes cluster. We've actually built, over the last 3 years, a community cluster program that's kind of been on steroids compared to the previous work that we've been doing. And so the idea behind the community cluster is, can we develop a mechanism where we pool the resources available to people on campus and go after and secure a common set of hardware. And in our case, we typically will have 5 different flavors that faculty can choose from. These are put together into a large system, and the pact that we kind of make with the faculty is, if you participate as part of the community cluster, we will help you take care of it. We'll provide the system administration. We will provide the back-end services. We will allow you to, run the applications. We will get you access to the number of nodes that you've purchased, typically within like a 4-hour period or less. Now, in exchange of that, we will also allow people that have purchased nodes to borrow idle nodes. So most people's research goes in cycles. Not everybody was able to keep whatever equipment they own, whether it be a mass spec or a computer node, busy 100% of the time. But oftentimes what we're finding by pooling faculty together, that we can have a much higher overall utilization and people can borrow to meet kind of their peak loads. So right now we have 3 clusters that we've implemented. We have 95 different faculty members that have purchased in, which is great. We have 16 of those that have purchased in multiple times. I found this interesting. Bill Whitson did a little work for me and said, how many hours have we computed since we began kind of the large community cluster? We're darn near 200 million hours, which since May of 2008, that just seems tremendous to me. It's about 80 million hours a month. 21 million jobs. And again, we talk about the number of users. Even though we have about 100 users, we end up with having a little over 6, almost 7 users for every faculty member. The total faculty investment has been about $5.1 million, so that's what they've bought. What ITAP and the institution has put in is about another $5 million in the back end of it, in terms of getting the racking, getting the networking, getting the storage. So we're matching, essentially dollar per dollar, the investments in the hardware, the cluster. And finally, there's about $1 million worth of savings by pooling together purchases. We're able to, pick on the vendors to try to get them to lower the price. And we've been quite successful over the years. I don't expect you to read this, because I'm right up here and sometimes I'm not sure I can. But each one of these colors represents a different department. And for me, this is almost a sign of success. What we've seen, particularly over the last couple of years, we continue to add more and more departments as represented by more and more colors. We do have big computational users, our biggest ones being in electrical and computer engineering, mechanical engineering, chemistry, and physics are kind of these big colors right in here. And then we have other disciplines that have been joining us as they've found the need for various types of computational science. So you'll see people in forestry and natural resources, communications, horticulture, also joining the community cluster effort in terms of getting some of their research done. There was a brief discussion about hubs in one of the earlier sessions. So the Hub Zero platform is what the institution has done in terms of leveraging what we've done with the Nano Hub, being able to essentially extract the key components that will allow us to apply this to other projects. And so at this point, we have over 24 hubs in operation. And the interesting thing is a number of the big grants that we've received on campus over the last several years all have a hub tied to it. And there'll be more of a discussion about the hubs tomorrow in a session. A couple sessions ago, we had a discussion about some of the visualization efforts. Kerry Troy looking at his Lake Michigan. This over here is a virtual pharmacy, a pharmacy clean room, allowing students to walk through. And if you have the opportunity to stop down in Envision, which is between Stewart Center and the Union, I encourage you to do so. We also have, in terms of the efforts, for some people, buying the big machines is absolutely essential. They continue to pound on it, and such. We've also built up a pool that we call DiaGrid. And the best way I can relate to this is, everyone here, well, most people here, probably have a computer at their desk in their office. And so right now that computer, at best, may be just consuming electricity. Just kind of sitting there idle. Maybe it'll do some updates, maybe not. So what can we do if we harness all the computational power of the computers sitting around campus? And at this point, we have more than 36,000 cores, not only from this campus and places like the Instructional Computing Labs, but we have 9 other institutions, with the University of Nebraska, our newest Big Ten member, joining us this fall and contributing almost 5,000 cores to the effort. If we had to purchase all this computer capacity, I'd have to find another 2,000 square feet of space, and it would cost about $3 million for that equipment. And that would be a very big challenge for any of us to come up with. Well, actually, the space is probably even harder than the money at times, is to find that kind of space to be able to house that computing capacity. And so this allows us to take advantage of the computers that we already have on campus and be able to utilize that for computational science. Talk a little bit about teaching and learning. Again, I want to go back to, I think the foundation of a lot of the cyber infrastructure is really all about the people. In this case, we have a different type of set of people. So we have people that specializes in educational technology, instructional design, web development, web programming, and those types of things. They're really all about what can we do to support the integration of this type of cyber infrastructure in the teaching and learning environment. What can we do in terms of developing new technologies that will solve instructional problems that we see here on campus. Some of these things you're probably quite familiar with. We're the ones responsible for the course management system, which is really just about delivering content to students. Some people will use it for testing. We also have other things such as Adobe Connect that is used around campus to collaborate both for the teaching and learning space as well as for research. The clickers, there are several types of clickers. We try to work with the faculty on trying not only how do you use these in terms of how do you deploy them in a classroom, how do you deploy them in a place like this, but what makes most sense? What are the best strategies for using these types of technologies in class? Do you use them just for attendance? How do you build interaction in the class? And I think facilitating that type of interaction. We also have a tool that we support for the institution. It's a survey-based tool called Qualtrics. And it's all about how do you get feedback? How do you do surveys? And you can use that, in terms of Purdue people for surveys both here on campus and other locations. I also feel an important piece is about innovation. And in our interactions with faculty, it's how do we find new types of applications? How do we meet the needs that are out there and emerging now in terms of teaching and learning? And so we've come up with a current set of applications in which I'll be talking about, but we're also interested in engaging with people here in terms of what are the problems on campus? What are the challenges? Have you sat down and said, it would be really nice if I could do X? And that's how all these types of tools have emerged over time. So the first one I'll talk about is about signals. And signals is probably the first tool that we've rolled out in terms of scale. The idea behind signals is what can we learn about students that would allow us to say, hey, you're falling behind, you're at risk in the class. The challenge has always been, at institutions, Purdue included, identifying the students. So initially this started out by saying, oh, we'll look at the application data and then we'll recommend to students that they join this program or they attend these sessions, whether it's be a class on studying skills or such. And then it's kind of evolved to the faculty saying, okay, can you please tell me which students in your class do you think are falling behind? And that just started out being, okay, just send me a little inter-campus memo, and then we really upgraded things and we went to the web. And the challenge behind that was always, you never got it back fast enough in this mix. So by the time you got a response back from a faculty member, because they're trying to deal with everything else in their class, you may not have good timing between identification of a student that seems to be falling behind and being able to do anything about it. So what Signals has been doing is it looks at some of the data in the course management system, looks at some of the effort that they're putting in terms of this course management system, taking a look at the grades, if we know anything about the student's academic preparation, and make a prediction of whether they're falling behind. And then we give them a red, yellow, or green light. Red is stop and get help. Yellow is caution, you're falling behind. Greens keep going. And the notification goes to the student. It also goes to the faculty member. And right now we've been working with a company by the name of SunGuard to actually expand this concept to include more and more type of data. So at this point we have a release that we've been working with here at Purdue. And then over time it's going to try to pick up additional type of data to see whether, based on student behaviors that they're exhibiting, can we identify students at risk. Because we have a lot of services for students here on campus to help them. The real challenge we have is trying to get the right students to go and take advantage of the services that we have. Kind of going in almost chronological age in terms of some of the implementations. We implemented a package over a year ago called HotSeat, and it's very much just like this group. Most of you probably, well, we have a few people with laptops. Most of you have some type of phone. Some of you may have other types of devices. Well, can we take advantage of those devices in the classroom? Can we go beyond just having the clickers as part of that? So we took, in terms of HotSeat, being able to go beyond just having an A, B, C answer or a 1, 2, 3, 4 answer and allow students to post questions that the faculty member can see. You get some rankings in terms of the types of replies, what people are looking at. And so you're able to engage the students in the classroom real time with the tools that the faculty members have. And then we get into, in terms of the next one that has been released really this semester, is called Mixable. Mixable, the whole purpose behind it is to take advantage of the social learning environment that students are already engaged. So some of you are probably already involved in Facebook. So how many people are involved in Facebook? Actually a little lower than I thought, but okay. So we got, probably 60, 70%. How about Twitter? Much fewer. Most people don't like to spend their time, chronicling their daily events. Students have already built up a network. They've already become familiar with a set of tools. They've become familiar with the way that they like to interact. So how do we take advantage, how do we harness this so that students can use these networks, and how can we grow these networks on campus? So as I explained in terms of Mixable, it's just kind of a layer on top of these tools. So you end up having a layer in which the tools that the students use, and then you also have a layer that is from the institution that allows us to tie student enrollment information. So when the student goes into Mixable, they're given a choice of whether they want their presence to be known. And if they want their presence to be known, they will actually see their list of classes, and they can start communicating using these types of tools with their classmates. So you save the time trying, having the students go around, trying to figure out who's their classmates, how can I reach them, whether it's Facebook or other types of tools, and then they can decide whether they want to kind of expand and interact in that way. When the class is all done, they could decide, hey, Chem 115 is done. I don't ever want to go back to that group. And actually just click the exit and kind of move on. In other cases, they may decide to stick around in that group and continue to glean and use the information that's available. And then finally, the last tool we've been working on is based on the need for different classes to use video. And we've just deployed this actually in the first class in November. Happens to be a forensics class in entomology. And many of your phones already have a video camera. And it's becoming more and more popular. So what can you do in terms of enabling students to utilize video on a device that many of them have and get it back into a format that you can use? So having all the students take a video, or groups of students take a video and say, okay, send it to me by email, becomes almost impossible to deal with. You end up with a lot of large files, and then you got to figure out, well, how do you turn around and give students feedback? How do you allow other students to give feedback? And so what DoubleTake does is allow students to take the video. It gets uploaded. It actually uses the diagrid system to compress the video and allows the students to go ahead and view the video. It also provides a scoring rubric that the faculty member creates where the students can rate themselves, or the faculty member can rate the individual students or groups of students in terms of the video. And so it allows you to have a different type of interaction. And then the final one that I want to bring up is, sometimes it's just a challenge to get a point across. And so we worked with Jay Malosh here at Purdue. He has had this calculator that we're now calling Impact Earth. What happens if a large body hits the Earth? And this allows people to take and look at different aspects of it, and will give you kind of what the end result is. And in many ways, this is taking the research and making it more accessible, not only to students, but to the general public. And so they've had a kind of a command line type of based system for some time, and this enhanced it. So with that, I'd like to open it up for questions, and then we'll move on to the next panel. Yes, sir. Oh, someone? No? All right. Oh, I'm sorry.
Oh, okay.
Nikki to the rescue.
Great. Well, no, I saw questions very well articulated without the microphone, and then they had to be repeated, so that's why I was waiting. Now, John, I was wondering what the process is for identifying these projects that you're working on and how you allocate resources to see them through, and kind of what their life cycle is.
Boy, I wish I could give you, this is the nice development plan for all these. Doesn't usually work that way. So oftentimes with the projects, we look for commonalities amongst the people that we're working with. So are there similar kinds of problems that we see? So we see a lot of people using video in the classroom, and they're all over the place. So they kind of open up an opportunity. In some cases, the origination of these ideas came from the staff themselves on how they interact with the faculty, how they interact with students. So in the case of Mixable, there was a whole series of interactions dealing with meeting with groups of students, trying to get an understanding of what is their challenge, and trying to use the social media that they're doing, and how do we apply that into an instructional context. The life cycle becomes a more interesting challenge. In some cases, so in terms of HotSeat, we've actually have a website that allows other institutions to download the code and use it as is. And so they provide a small fee, which I think is $2,000. I get a nod, so that's, and the institutions can take the code and kind of move on with it. And so we're looking at different models. We know we cannot be in a place where we sustain all applications at all times. Just not possible, because we'll end up just being a software support organization. So we're looking for opportunities like the signals. We knew we couldn't grow it as fast as the faculty were looking for new advances. So we got to go find a partner. In that case, it was SunGard. So we're looking at multiple. Not a clean answer, but hopefully that gets at somewhat you were asking.
My question is about the clicker thing.
Yes.
I found this semester, I used the old one, it's called CPS.
Yep.
And I learned this semester my student have two devices. One is
Yep.
iClicker, one is CPS. And I wish, well, that's something, if I knew at the university level that what's going on, and then I would not make the student buy another device. Okay. So next semester I'm switching to iClicker.
Right.
But the problem is I found out iClicker at the web base is cheaper than the device. So there's no coordination in terms of, I guess, professors don't talk to each other, especially across the department. With the economic pressure there, I think we need to find a way using the cyberspace to help us to communicate with each other, coordinate. Like if I know, well, right now I'm pushing for the web base because it's much cheaper for a student.
Right.
But I don't know how can I make the other faculty to really think about that way. The iClicker web base can be used with existing device. You don't even have to buy another device.
Yep.
Okay.
If you have any great suggestions on how to get faculty all in one place, I would love that. You know, the clickers particularly have taken interesting evolution, because if you go back like 7 years when we originally adopted CPS, we did get a bunch of faculty all in one place. But the technology changes, and you know, stuff like iClicker is, and quite frankly, easier to use than what we originally adopted, because it hadn't kept pace. And we're going to be continually faced with those challenges in terms of getting faculty at least aware, maybe not necessarily in sync, but at least aware of what people are doing and what the impact is on the students. And I think that's going to be a challenge of any post-secondary education institution, partly because the faculty have an independence in terms of what they do in the classroom. So any other questions? Because I know we're about actually a little. We'll take one more question, and then we'll move on to the next section.
John, how much
Yeah.
of the software is created at ITAP versus, like, say, outsourced? Like, I guess my one specifically is like Mixable.
Mixable is 100% created here. So I'm trying to think if I could even come up with any outsourced software development. And I can't think of any example in terms of my group. The research side of things, there are some faculty that will outsource pieces, but usually it's to other higher ed institutions. All right, so with that, I'm going to turn it over to Peter.